Welcome back to All Things Data Science, the one-stop channel to help anyone interested in learning or transitioning to data science just like I did. We are in the LeetCode series and specifically the easy section and sort of more, let's say, the math section of problems. So let's jump right to it. The specific problem we're going to look into is the palindrome number. And we're still here on LeetCode.com. For those unfamiliar with the website specifically, some other videos go a little more in depth into it, and I could make one that is a bit more specific and sort of explores it into more depth. So what do we have today? Let's hone into the problem set, and really even before starting here, I do want to mention that we're going to begin with this sort of what I like calling the meh approach. So it gets us thinking about the problem set, but we can do a little better afterwards. So here we are. What are we given? We are told that as our input, we are going to have an integer. They're calling it x. And all you need as your output is really just whether it's true or false. So looks like it's going to be a Boolean specifically. So that seems pretty straightforward. Then they define the problem set. A palindrome, and I'm sure a lot of people have heard of that before. I mean, you can think of sort of ABBA, the variant of the singers. That's technically a palindrome because what you're seeing on the sides are really kind of mirroring one another, but it could have also been one where it's an unpaired number of letters in this case, though since we're in the world of integers, you know, they're giving us the example of 1, 2, 1, so same thing, palindrome happens to be where the middle case is not basically making a difference. The fun ones really here, and I'll put it in red, is that they're also accounting for negative numbers, but we're gonna keep an eye on this one because does it even ever become a palindrome? And of course you're not gonna have sort of a negative sign on the end because then that's not a valid integer, and here they sort of reconfirm that you get a false with a negative number. So that's sort of the general idea of what at least the problem is asking us about. Now, what we have on the right hand side, like I said, is for us to get us thinking. So it's not at all the final solution, but sort of what's going on here. So a couple of things. All right, how do we think about this? I think it's natural to think, all right, maybe convert to a string. So, you know, we take an int and I do a string, and the reason is it's kind of hard to, and it's not quite true, but it's harder to sort of be specific into you know, indexing into specific parts of an integer specifically. So generally, at least with strings, you know, you could say this one is of index -1, this one is of index 0, this one is of index 1, or it could also be -2, depending on whether you're going in this direction or this direction. So it just feels, you know, that strings is and generally, I mean, that's all of this stuff is little things I've written, and generally that's the first thing sort of one thinks about. So how do we go about that? All right, we say, let me do my little conversion over here, but also, why are we doing this? Actually, for some people that may not recognize these signs, the double slash really just means when you do a division, actually the best thing is looking at this in particular. If you didn't have anything that's as a remainder, basically 0 really, That's fantastic. 3 makes total sense. But then for the ones where you do have some kind of remainder, this slash slash really kind of represents that part that you would get as a whole piece, and then whatever is left as the remainder is a different one. But speaking of remainders, which we will use in sort of other parts, not quite here, but for example, that's the sign. This one is going to be sort of your remainder at the end of the division. Okay, so we have that going on at the moment, but what else is there to explain in here? Why are we doing this whole mid-index? Well, initially there's this idea of we're kind of mirroring somewhere, right? You're either going to be smack in the middle somewhere here, so -1, and then you can imagine a vertical bar. Or it's going to be an odd number, and then it's going to be somewhere here. But really, I mean, when it comes down to is you're not going to be pursuing the full number, or in this case string, since you just need to compare sides to sides. So eventually I'll change some of these terminologies in the other solution I show. But one thing I wanted to set us up here is some silly things that one can run across is we talked about an array being indexed at 0, and if you were to go backwards, then you don't do a -0, but you do a -1, of course. So in this particular case, right, or actually, since it's an array, this is going to be 0, but this is not, -0. It's -1, and so that's why here you actually get a problematic where you're not getting what you're expecting, because what it's just doing is the -0, but rather you should set that up so that it indexes properly. Now, other things too, so that's what we're seeing here. And then like little things that I had noticed really initially on is you do need an output being a Boolean. Even though the letters are sort of lowercase and they're problem statements, it didn't mean a string. You need to be very careful about what's being asked specifically. Here they're not as specific, but here you do get a hint that it's an actual Boolean. So you'll see later, if you had kept it as just strings here, then it'll always be true, and that was a little bit funny, and that's why I have my little print statement here. But enough on this sort of very beginner, silly kind of attempt to the problem. Now we take it a step further, where we're still in the world of strings. However, it's sort of a working solution, and so the pieces that we're taking care of is we're still doing the middle index, since we don't need to go all the way through, and we just need to flip around, play around with the indices, so that you're sort of coming at the problem from, as I'm stating it here, with the variable names, the left side, and then you sort of come at it from the right side. So what does that mean? You get your little 0, but here you're being careful about your indexing, so you come you're going to start indexing negatively, because that's a nice way of traversing a string from right to left, but you're adding your little +1 given what we discussed earlier. And then really what it comes down to, this is what we had before, you really don't need to account for whether the piece is odd or not at the end of the day, because you'll either sort of hit the middle and you're good to go. Say if it was 6, then you've kind of looked at 3 on the left and 3 on the right side, and you're comparing them. And otherwise, if it was not, then you sort of just have that middle element that doesn't matter anyways, because it'll be the same in a palindrome. So that's sort of an interesting one, where you might not need to explicitly try to see if your number of digits, i.e. how many numbers you have, is that pair or unpair. I use this a lot, but a while loop would be, for example, a different way, a little bit cleaner. But basically, as you're traversing from left to right, as soon as you hit something that is showing you that these two numbers, for example, here, if we do the example that they propose, then the -1 and the 1 are not the same, and so it should be false. I mean, here we could do it with a little print statement or something like that. So, but now the other things to keep in mind is generally when you're coding, you should keep attention to little wins that might speed up your process a little bit. And what I mean by that is here, actually, if we think about it, if any of your numbers were, and we could test it out actually, even something as silly as this, where it's almost all the same, but you have a 0 on the right-hand side, that should be a false, and the reason is you're never going to have a 0 on the left-hand side, otherwise it's not a legitimate actual integer. So those are quick wins that one should check for, as well as what I was hinting at the beginning. If you do have a negative number, then same thing. You're just never going to end up with a negative sign on the right-hand side. So those are things worthy of removing from the get-go. So now sort of hitting the slightly better approach. I still think there's always room for improvement, but this is going off of the proposed solution. So what they say here is, assume you didn't have the option of actually converting to a string, because that's not great. And it's not great in what sense? It's fine to a certain extent, but you are now using memory in order to save this extra thing that you maybe didn't need to. So that's always something to keep in mind. Right now we're doing, 4 numbers, digits type integers, but really the input that you could have is 2 to the 31, and think of things like molecules or things like that, where these could be real examples and you can't play around with saving things. And actually they also mention the reason why in the solution they're going to do sort of looking at half of things is you also quite genuinely, and for people that don't know, can run out of space in memory. And that's something that, if the idea that we're trying to do here is stick to integers and not do any string conversion, is let's recreate the numbers. So here they give a good example, 1, 2, 2, 1. One thing to do is let's look at the half, and then we're going to recreate this number going from the right-hand side and kind of inwards towards the left-hand side. And for example, given that you start out with a possibility of 2 to the 31 length, basically integer, it could actually overflow if you're flipping that whole thing. So you should look at doing half, literally for memory reasons, but also the problem is set up such that that's what you should do, because we're looking at palindromes and this whole idea of mirroring. So you really do not need to look at the whole string. And here, it's a very elegant solution, and I disagree with a couple of things here, but I'll get to them. So, don't take some of the comments they have in the solutions, to the letter, but it's a very good solution. But one thing I think that's worthy of discussing in this one is sort of going back to a traditional way of doing division, things that we did in elementary school and middle school. And I think different people study it differently. But at the end of the day, really, what it comes down to is, let's take an example like 1, 2, 3, 4. So in Python and in computer science and this whole sort of data structure world, you're always sort of looking for these common tricks. And we've seen a few in a past video that were a bit more kind of related maybe to arrays. Here for integers, it's very, very common. We already saw that whole modulo that gives you the remainder of your, when you're doing a division. And then we also saw the kind of main part that you get out of a division. And let me be more specific on what this is before I move to actually doing it. So what that is for example, if we do, I guess the what we had shown, a 5 divided by 2, then that's going to give you a 2. And the 5 divided by modulo in this case, 2, we clearly know that 5 is not a pair number, then it's going to be 1 because they're twice 2's in a 5, and then you kind of have a remainder of 1. So a couple of tricks for everyone is this is often used to figure out if it's if you have a pair or unpair number. Which in our case is clearly unpair, so it would have been equal to 0, and otherwise it's equal to 1, but you could also just say, is it different from 1? So those are the couple of parentheses with regards to division and things that are useful with integers in the world of data structures. So now going back to the actual division and seeing how it's going to be helpful in the math part that solves this problem. So if we go back to the 1, 2, 3, 4, let's try to be smart about this. If I divide, so this is another very fancy one. Division by 10 specifically is great. So the division by 2, we saw it's impair pair, and then division by 10 is a great way of grabbing a specific digit. And what do we mean by that? So how many 10s do I have in this? So I think we've all done this back in the day. So here we've got a 10, you've got 2 left. I move to the next thing, 23, 2, 20, and you do like your little minus here. You have 3 left, and then 34, 3, and then I guess to be more specific, I'll continue that way. And then you end up with a 4, so this is your, remainder. And this is what you would have gotten from this kind of a division, and this is what you got from that modulo. So, so here, what's wonderful, of course, is now you've gotten this, which is basically grabbing this particular guy, which if we started talking earlier about wanting to eventually flip the numbers, then this is the number you would start with, and then you would want a 3, and if we had an even longer series, then that would be great. So if you had a 1, 3, 2, 1, then what we would have gotten right now is this piece, so that's a 1, and then you're going to add the next one afterwards 2, and then this is sort of your mirroring, and you see that these two equate, and so that's wonderful. So now that we see how this division and this importance of the modulo 10 is doing and divided by 10 in general, what's happening is 2 things, and basically this is the proposed solution, but it's in C#, so here's an equivalent, for instance, with Python. Here we're just solving what we talked about earlier, the things that weren't quite taken care of over here. So if my number is negative, then there is absolutely no point of me even thinking about this, so let me directly say that it's not a palindrome, and then I do my little modulo, so remember this is for the remainder, and this is a great way of seeing that if my last right digit basically is a 0, and then in this one, really, because if you did have a 0, then that is a palindrome in any really singular digit, so that's sort of what is happening over here. So now, I mean, this is the part that is slightly debatable, but it doesn't matter because it it works out afterwards. But in this case, what I mean is we're trying to hit the middle. So this is one approach of saying, look, I'm gonna keep on going with this 1, 2, 3, and eventually, for example, 12 is going to be maybe bigger, or actually, especially if this was not a palindrome, say if it was 2, 2, and then 2, 1. So you would have a 12 versus 22. And so what they're saying, while I still have a bigger number, then I keep on going. So that's sort of a little bit what's happening. And so if you do keep on going, then you're kind of add the other digit, right? 1, 2, and then one more to the left. So what's happening over here, and I think the best way is also to draw on it, is, let's keep that example of the 1, 2, 3, 4, and you're kind of going through, really, and so 1, 2, 3, 4, what am I getting? I'm going to do so 1, 2, 3, 4 is your original x, right? What you're going to do to it is this part first. So you're going to say, what do I have as a remainder? Remainder is 4. Fantastic. That's exactly what I want to use to start building up this sort of reverse number, right? So let's call it reversed number. And there, I'm filling in, I got my little, I got a 0 times 100, because that's what I have so far over here as my reverse number. So I've got a 0 really times 10 plus the 4 that I just got. And I see that my actually, before getting to comparing the x, then we say, alrighty, let's now take this one out, and really what we're left with is an x that's equal 1 to 4, and that is bigger than 4, so I'm going to keep on going through the loop again, and you do that. But basically what's happening is, I think you're starting to see it now, is at the next iteration we're going to start building upon that 4. So we used to have a 4 and just a 123 specifically, and as you saw much earlier, right, this makes sense now why we were left with 123, because we did that little division part. We got the 4 that was left, and we got the other piece, really. It's a neat way of kind of dividing or separating what makes up an original number. So we've got this as our x, we've got this as the reverse number, and now we just do it again. So what we're trying, again, the goal is really to build from right to left. So we grab this guy, and now we want to build it up, right, such that you're sort of pushing that 4 to the left. So you time it by 10, that's what's happening over here, and then you add to it the 3, which you managed to get again from that same operation, the modulo 10. And then you've got a 12 and a 43. And in this particular case, because we're comparing x and 43, then you sort of stop here, and then what you do is compare. So you say, all right, are these two numbers actually the same? That is not correct. And then if you were, as they're explaining on the left-hand side here, if you had sort of a I guess an impair number, then that's what this part would do. But you have a Boolean, so it's, if either of them is good, really that's what's going to go through. But in this case, they're both wrong. The only thing that I think is different is I still think this approach is a good one. But I wouldn't say it's just because of the unpair is really when you get this possibility. What I mean by that is we could have, for example, had the number instead 9, 2, 3, 5, or sorry, just 2, 3, 4. And in this case, you would actually end up with 92 being indeed greater than 43 and you would have gone actually a step further. So that's just something to keep in mind. But really that's all, and that's the end of this particular solution. Please feel free to provide any comments. Don't forget to subscribe, it's on the bottom right. These are just initial approaches to trying to explain these problems, the way I find that there are certain highlights to be pointed out, but I'm happy to set up the explanations a little more differently if need be. So thank you, and until next time.